Oh, we got to stop that. All right. So this one gives you a uniform distribution from 0 to 75, right? You might be the unlucky schlub that has to wait 75 minutes for the bus. 100 riders are randomly sampled to learn how long they waited. Okay, so they take 100 riders, right? Riders on the storm. Let me see. Somebody else is coming in. The 90th percentile sample average wait time for a sample of 100 riders. Oh God, there's a lot to unpack there. So they want the 90th percentile for the wait time. That's what they want. If it was, it's no longer a uniform distribution, right? Why? We're not working with a uniform distribution for number 81. Does anyone know why? Does anyone know why? Let's see. Let somebody else in. Yes, Sarah. So two things. The sample size is greater than 30, and we are talking about the sample means. So the sample means don't follow what the individual scores did, right? The individual scores follow the uniform curve. Sample of size 100, the sample mean is going to follow a get out of here, Jeff, a normal curve, right? So we can get some work done before we know shit about anything besides this. They want the 90th percentile, right? Let's see, it's almost time for class. Maybe I'll wait. I'll let you guys think about that for a minute. I'm going to do this one with the whole class, I think, because there might be more people with the same question. I was going to ask you if that's all right, Victor, but that's what I'm going to do. So it's okay. it's got to be okay. But that's the one we're going to look at first when 9 o'clock rolls around. Try to see what you can do. Yeah. Okay. Just think about 90th percentile. Where would that be? You know it's normal because we're talking about the means and ends greater than 30. Can you find the z-score for the 90th percentile? And then you got a decent amount of work left to do. That's a good first step. Jeff finally got new markers. So exciting. And look at this shit I got. I got like a real eraser. Oh, wow. And I got like real cleaner stuff. Oh, wow. What a horrible world. We're so excited about markers and cleaning stuff, but oh. We got about 4 more minutes. Any other questions I could just put off till later? That's a really good question, so I want to kind of go over it with everybody. Does anybody else have any quick questions or any other ones you want me to go over once class starts? No, okay. That'll make that easy. Oh yeah, it's outside. Bum, 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 bum. Oh. L. Let me see if I can find something. Whoa. Intriguing. More people coming. Where am I at now? I got 16 people. That's not quite enough yet. ¿Dónde está? Let's see. No, I don't want interquartile range. Come on. Barf. No. Oh, well. Shoot. I almost said shit. All right, let me see. Well, Jeff, all right, dude, just go to this one. Get down there. Get down there. If you're just joining, I've got one question somebody asked me. I'm waiting until 9 to kind of finish it up, but it's number 81 in chapter 7. So if you had any trouble with that, we're going to go over it first thing. If you have any others that you want to take a look at, let me know. Holy crap. All right. We're almost there, guys. A minute and a half, I think. Whoa, here comes people. Okay. What? Yeah. All right. Sorry, guys. I'm just looking for something to show you. Yeah, dude. What do we got? We got less than a minute. 8195E. All right, let me write that down. We're almost. This is 81. What was this one? This was 81, number 81. Not 81, Jeff. Get out of there. This was chapter 7, number 81. I don't care what section it was. Who gives a shit? It's just number 81. All right, who else do I have? He's coming in. And then you said 8195. All right, I'll make a note of that. Okay. Oh, is he gonna come in? It tells me somebody's entering the room. They're taking a long ass time to get through the door. What do we got here? Oh, it's time. All right, so I've collected 2 questions so far from homework that people want to go over. Man, why are they not getting in? Do I look okay to everybody? Is it not like this? This is never okay, but my Wi-Fi, am I coming through okay? Okay, good. Thank you, everybody. Let me see. Okay, so we have 2 questions. Here's somebody else. One is number 81 in chapter 7. Oh crap, everybody's coming now. It's just like when we're on campus. A minute after, they're running through the door. Oh, see, here they come. All right. Number 81, chapter 7 says we have a uniform distribution. Uniform distribution from 0 to 75. This is waiting times for a rural bus. Rural, hard word to say. 0 to 75, right? It's uniform, but they take a sample of 100 people. So I'm just going to cut to the chase. If we're talking about the sample means for 100 people, then they make a normal distribution. So far, so good, right? Everybody's got to be with me. The individual values make a uniform distribution. That's what it tells me. But the sample means become normally distributed because n is greater than 30. Beautiful. They want me to find the 90th percentile time. These are times waiting for a bus. So where would the 90th percentile be? In the picture, of course. To the left or to the right? To the right. Take one step to the right. Oh, sorry. So this would be 90th percentile. I like it. So you could find the z-score there, right? Totally, very simple. It should be a z-score that looks very familiar. So here's the z-score. You're going to look that up. Now, how do I convert that back into a sample mean? They want the 90th percentile sample average, sample mean. How do I convert that back? That's a weird one for you to answer. You might want to, okay, that's a good first step. So I'm going to use this formula here, right? Talking about sample mean, so I got to change the standard deviation. So now the real work of the problem comes in. This was old news. This is very old news. Now we've done a problem like this before. I don't even know. How do I figure out what that is? Well, it's the same as what the original one was. How do I figure out what this is? Well, it's equal to the original divided by the square root of n. Do we know what the original is? No, we don't. No, we don't. No, we haven't calculated it yet, right? You've got to calculate the mean.
I think it's so funny that this girl always, she's like one of the few girls that has her webcam on, and she always looks so cute.
What's happening? Who's saying something? What? Did anyone need to share with the class? What the hell just happened? All right. Neat. All right, so coming back from describing other people. All right, I'm going to mute everybody. Don't make me turn this class around. Okay. So I've got to figure out what the original mean was, and I've got to figure out what the original standard deviation was. We've done a problem just like this, where it starts off uniform, they take a sample. I think it was the songs one, where the sample is 43. So we had to figure out what the original mean and standard deviation were, and then I can change that to become what it is for sample means. So the new thing here is, there's a couple new things. One is they didn't tell me the mean and the standard deviation. I have to calculate it. But it's those formulas for uniform distribution stuff, right? Is everybody okay with that? It should be enough. This is desperately got to fill this part here, 90th percentile, get the z-score, throw it in to convert it. That's old news. The slightly new news was getting the standard deviation and then, of course, changing it because we took a sample of 100 before you throw it into this formula. All right. Maybe. Is that all right? Any follow-ups on that one? That one is definitely more work than you might think for a multiple choice or multiple guess. You got a 25% chance of guessing right. But too bad I want to see work. All right. Okay. And then the other question was, I can't even remember my own writing. Was that number 95? Let me see. 95, E specifically. From chapter 8. Let me see. Bam. Ooh. All right. Let me share my screen. It's over there. Okay. Oh, I see. So this whole problem is they give you the information you need to construct a confidence interval. So you do all the work, and then part E, you can actually answer. You can actually answer without doing any work, which is always nice. What would happen to the level of confidence obtained? Now, this is kind of a weirdly worded thing. Yeah, I agree with you. This one's poorly worded. They have to mean what would happen to the confidence interval, because we are constructing a 95% confidence interval. We already know it wants to be 95% confident. So part E should say what would happen to the interval, to the confidence interval. Would it get bigger or smaller if we surveyed 1,000 male Swedes instead of 48? Whoa, I get some chats happening. I can't even see them. Oh, okay. Okay. Was that your question, Marie? Let me see. Oh yeah, that's your question. It's kind of poorly worded. I will give you that because they are saying they want to construct a 95% confidence interval. So of course the confidence level will be 95%. So they should have worded it differently if they said if we keep the confidence the same, but we increase the number of Swedes we looked at, if you get the interval the same, then our confidence goes up. I know that's kind of weird, but it doesn't, if they meant to ask that, they should have asked exactly that. So I will give you that 95E is poorly worded. I will give that to you. Anything else from homework stuff? You're welcome. Let me stop sharing. Feels weird to share. I don't like to. It's mine. Give it back. Anything else? Anybody? Okay, so let's get back into where we left off last time, which was with this. Where are you? There you are. With this handout. Here it is. Bam. We did this side last time. Correct? Let me see. Get out of there. Oh, all of this shit's so weird. All right, there we go. I am freaking out on my side. Am I freaking out for anybody else? Sorry, I'm tripping out. Sorry, everybody. Oh man, things are really weird. I look good on that side? Okay. On my side, I look like Max Headroom, if you know what that is. I'm going crazy. Not a good sign. Let me try to shut some stuff down. Shut down. Let me see. What do I have over here? Not much. Let me shut you down. Shut you down. I'm going to look at you in a minute. Okay, I seem to have calmed down now. Okay, good. Sorry. So we did the dolphin one. I think we looked at this first row of stuff, and I talked about doing this. So if you missed last class, well, that's good to know, Alex. Alex is cool, everybody. Sorry. We talked last time about what happens to, how do you determine if a percentage problem is normal enough? Well, how do you determine if a problem about means, if it doesn't say it's normal, we all know how to determine if it's normal. N has to be greater than 30, given. We know that shit. Well, what about a percentage problem? It can't be the exact, it could be, but it isn't the exact same test. The test has to involve the percentages somehow. So we talked about this last time. Right here, the NP and NQ, get up there, have to be at least what? Those two have to be at least 5. I love it. Kick ass. So I think we might have done a little bit more than I've got written here, but I can't remember. So if we do N times P, 652, and times P hat, of course, times 0.704, what do you get from that? What's it look like, Jeff? I don't even feel like doing it. What do you guys get? Uh-oh, question. How do you get the document to get it typed? I can't get it. I have to draw it each line. One I meant about, I got to have it. Oh, Alex, you're fine. I actually, to be really honest, I have uploaded this handout into Canvas. There's a place that's called Test Student. You guys see up here where it says Test Student? That is me. And so I can upload it because I really do like the ability to draw and type in Canvas. So that's what I'm using. If you use something like Adobe Acrobat or something, you can't type and draw unless you pay some money, I believe. So does that answer your question, Alex? I mean, that's what I'm using. So yeah, some people are telling me 459.00. It's basically 459, right? Does anybody see 459 somewhere in this problem? Do you see it somewhere? Yeah. Now, real quick, you can do the work. It'll be fine. It'll be fine. But a little bit of a shortcut is NP, of course. Look at this equation right there. N times P hat will be X. It just will be. And then NQ is going to be the rest. So you could do 652 N times P and do it Or you can just say 652 minus 459 is, what is it, Jeff? What is it, Mr. It's so easy? 193, is that right? Yep. Right? All right, if you don't understand that, you can just do the NP, NQ, that's fine, but there's a little bit of a shortcut. The number is in the problem already. I already know what NP is, so I already know what NQ is. And those are both, get up there, at least 5. What does that mean? They're both at least 5. Whoop-de-doo. What does that mean? Why is that so freaking cool? Thank the Lord. Yeah, it's normal, right? I like it. So now that I know it's normal, I already have this up here. I don't remember if we got that last time, but I want to be, now you already know what the answer is for the z-score. Can you try to find a 96% confidence interval? So I'll draw the picture here. Let's see how it comes out. Not bad. Not bad, Jeff. Oh, God. Let's start over. Okay. All right. Sure, why not? Oh, crap and a half. Screw it. That's what it's going to be. I'm glad. I'm sorry you have to go through this journey with me. Yeah, we did, Ree. Everybody, we did this side, right? The dolphins. We definitely did the dolphin side. That's for damn sure. Yes. And that's why we're starting at the beginning of this one. This is on the reverse of that dolphin sheet. All right, this is section A1. And you're right, we have not done this. We didn't do this yet, and that's why we're doing it right now. So if I want to be 96% confident, I really hope your distribution looks better than mine. What will I look up in the z-score chart? Oh shit, is somebody trying to get in? Dun, 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 dun. No, okay. What will I look up in the z-score chart to find like this z-score right there? What will I look up? If there's 96% inside, how much is outside? Yeah, there's 4% outside, so there's 2% on that side. I don't know which way it's going to look right. So over here, this, you could do it, Jeff. There you go, buddy. That is 4%, 2%, sorry. 4% total outside, 2% on that side. You already know the answer is supposed to be 2.05, so just take a second and double check. Make sure you can find 2.05. I always sense that somebody out there is like, I have no flippin' clue what's going on. In fact, I don't. Where did my, there you are. Handy dandy z-score chart. So if you look up 0.02 in the body, I'm not even going to try to show it to you. You will get negative 2.05. So of course the other side is going to be, can you do it, Jeff? Positive 2.05 because of symmetry. And again, it's kind of beautiful that the formula's got a plus or minus in it. And that's related to the two z-scores to find the two sides of the interval. That's so beautiful. All right, so you've got everything you need now. Make the interval. You're like, oh man, what a great Tuesday morning. Come on, we can do this. You got the formula right here. You've got it. You know what P hat and Q hat are. You know what N is. We just figured out what Z is. Just to remind you guys, I highly recommend you do this part first. So then you can add it and subtract it to P hat. I'll wait. P hat. Oh man. I'm going loopy. Let's see. So let me get this set up here. Let's see. So I've got P hat, give or take, 2.05. Get in there, you silly. Times the square root, excuse my formatting, of P hat times Q hat divided by, oops, where'd it go? 652. Right, that's p hat, give or take, z times the square root of p hat, q hat divided by n. Wow. So when I put it in my calculator, this is what it looks like. Make sure, yeah, looks about right. Sorry. Okay. So that is the error, give or take, what did I say? 0.0366. Yep. You guys with me? I really hate not being able to see everybody. It just sucks so much. But if nobody chimes in, I'm going to have to assume everybody is with me. I left off the point here, sorry. It's not 704%. Holy shit. So all I got to do now is subtract 0.0366 and add 0.0366. Oh, crap. If I could type, and if I had a hammer, let's see. I get those two things. Don't worry about how I did it. I do things in a nifty way. Ha, 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 ha. So I get 667 to 741. I get 0.667 to 0.741. Oh, shit. Bam. All right. Let me stop there for a minute. Anybody? Malachi's with me. I like it. It's like I storm out of the room. Who's with me? And Malachi comes with me. Who's with me? I am. So now I want to write. I want to write the conclusion. Your conclusion always has to have the units. For percentage problems, the units are the percentages. So convert those decimals into percentages. And the way you word your conclusion is the same as always. We are such and so confident that our interval, blah, 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 catches the real blah. All right, so let's fill in some details. That wasn't very detailed. Let me decrease my, see if you guys can still see this. Look at me. Just let it go, Jeff. It's okay. It's okay. You don't have to line it up, Jeff. You don't. There you go. Oh, fine. Okay. We are 96% confident. Oh, this is awesome. Good Lord and a half. That the interval what was it? 66.7% to 74.1% contains the true population. Get in there. Percentage of, then you plagiarize. People that voted. You have to reference the reality. Don't say, I'm this confident my interval does stuff. No, you got to give me the physical reality of what it is that we're working with. Oh, so I know it's been, a weekend and a few days, but this should feel very similar to what we did up here. We're just using percentages instead of sample means. The feel of it is the same. All right. So anything about that? I don't see any questions. I want to remind you, we did go through the derivation for this formula here last time, right here. How many somethings would you have to be sampled to be within something? That would be an n equation, because I want to know how many, and n is how many. We went through the derivation of that equation last time. I'm not going to force you to go through this one because it's very similar. Right here, I identify what the error is, and then I solve for n. And you can see why there's a bunch of squares, because I have to kill the square root, blah, 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 blah. Now, here's a very interesting question. So this is number 2. This is separate from number 1. how many people would we need to survey to be within 3% of the true proportion of students who pass statistics the first time around at 99% confidence? All right, so what can you get that you need for the formula from what I've told you? What's 3%? Where's that go in the formula? What's 3%? That's the error. I love it. So somebody tell me, what does E equal then? Don't say MC squared. MC2 legit. Hey. Anybody? Yes, it's 3%, but percentages are completely made up bullshit. It's what humans use to make more sense out of decimals. So you better use the actual number, which is 0.03. If you put 3 in there, you're going to get a sample size of like 0.82 people. And don't go chopping people up just because that happened, right? That's your own mistake. Don't be killing innocent people. Stop that. What else can I get from what I've told you that I need in the equation? So I need E. Can I get Z? Do I know what the Z score is going to be? Yes, because I say it's 99% confidence. And you guys, I showed you this, right? The little baby chart. I couldn't use it for the first problem, right? Because I wanted 96% confidence. 96 is not there. Ha, 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 ha. But 99 is there. Kick ass. So just be ready. I am going to make you make like 89% confidence interval. So you can't just use the little baby chart. But here, yeah, 2.75. So I know Z is 2.575. What else do I need for the formula? I need freaking P hat and Q hat. So see right here, I'm trying to give you a clue. If you don't know what the percentage is, what's your absolute best guess? If you have zero information about something, like what percentage of people, what percentage of rocks on Mars have a reddish brown hue? Well, that's not good. You have some experience by that. If you have no idea about anything with the problem, your best guess for the percentage is 50%. That's your best guess. That's the only thing you could say. What percentage of women are in the store down the road from me? 50%. That's my best guess. Is that what it is? No, I don't know. Maybe. So if they ask you, how many people would you need to survey to be within so much percentage of a percent of the true percent, and you don't know what P hat and Q hat are, you've got to use 0.5. So let's put this together. So now I know that P hat, let me see if I can write this without saying hate. There you go. P hat, yeah, but you can't do that. Q hat, both 0.5. And now, real quick, the whole purpose of 2A and 2B, in 2B, we're going to know what P hat is. Oh, your audio just cut out. Best guess is 50%, exactly. P hat and Q hat, both 50%. Mathematically, setting those to 0.5 makes N come out the biggest it could possibly come out. Which makes sense. If there's something I don't know, then the math that tells me how big of a sample I need should make that as big as possible to cover my ass for not knowing something. So let's do this. Let's plug it in. See what you get. You got everything you need to plug into that formula. Don't forget the squares on things. What time is it? Okay. I got, shit. We got to get through some stuff today. Please, Jeff. Come on. I want this beard to be like massive. I've never had an actual beard. I never had an actual beard. All right. So let's see. N equals 2.575 squared times 0.5 times 0.5 divided by 0.03 squared. Okay, so forgive my horrible formatting. I need some beard oil. Not quite yet, Lewis, but I did buy some for my little brother. He's got this massive beard. He's bald. It just looks like his hair just migrated to his. Yeah, who knows? Maybe I'll get some beard oil. Sorry, Jim. I don't know. Sometimes he watches some of my videos. Sorry to call you out, Jim. He's cool with it. He looks like Mr. Clean. 2.575 if he grew a beard. Times 0.25 divided by 0.03 squared. What do you guys get? Anybody? Oh, some of you guys, yeah, exactly. 1841.84, blah, 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 blah. Now, again, I don't want you chopping people up. So you always, no matter what, if it's not a whole number, you round up. Even if it was 1841.07, you would make it 1842. All right. In my other class, I got to, anyway, 1842 sounded like some historical. I was like, what the hell happened in 1842? All right, so you would need 1,842 people to get within 3% of that. Now, part B, I'm not going to guess P hat and Q hat because have you guys ever heard preliminary study? They did a preliminary study. And the reason you do that, let's find out why we do that. Can somebody tell me on part B, take a minute and figure out what the percentage is from the sample. What's P hat? How many out of how many from the sample? I saw 31 out of 42, right? So now we know what P hat is. We don't have to guess. We don't have to make it 0.5. What is that? When I was 42, let's see, 0.738. So, yes, thank you. Did I go too far? Sort of, maybe. Oh, Reed's trying to be, yeah. So, yeah, just round these at least to 3 decimal places. So you can go to 4, that's fine. So what's Q hat going to be? Two. 6. 2, yes. All right, like, just have to make 100%, right, between the two of them. I don't care what clothing they're wearing. These two are wearing hats. They still have to add up to be 1. And now just redo this work. In fact, I'm not even sure I can do this. Let me see if I can copy this. Yeah, Jeff. Ooh, look at you. Let's see if it works. Yay. So what I'm going to change in here is I'm going to change this to 738. And I'm going to change this to 262. Because now I don't have to guess 50-50. I actually know what they are from a preliminary study. So let's see what we get. All right, Jeff. Calm down, buddy. Neat. What have I done? Okay. All right. I think I got it. Let's see what you guys get. Another historical date. Anybody got that yet? Man, when I shave, it's going to feel so weird. N equals 14. Where'd it go? 24.52, blah, blah, blah. So I round it to be 1425. Yeah, that sounds historical, doesn't it? Is this some pilgrim shit? I don't know. Not quite yet, huh? 1492. Yeah, anyway. Oh, I better stay away from that. I'm not a history person, so. Yeah, but the pilgrim stuff. All right, shut up. So look. By doing a preliminary study, I have reduced the sample I need to take by over 400 people. That's one of the main reasons we do a preliminary study. There's many other reasons too, but that is one of them. Okay, I'm not seeing any questions, so I'm gonna continue. All right, and by continuing, I mean we're gonna get into section 8.2. This is section 8.3. And the main reason I did 8.1 and then 8.3 is because they both use this. They both use this distribution. So what I need to show you, let me see. I don't know how many of you can do this, and I should have said this earlier to you, but if you go to Canvas and you look on pages, right? For example, you'll see the photo to PDF, which is the apps for scanning stuff. I'm doing that weird thing again. Oh, well. Just always tell me if my Wi-Fi gets all freaky. And then right here, there's a new thing. There's the Z-score sheet. There's the syllabus updates. Here's the T-scores. I just uploaded that. What is that? Yesterday. So if you click on this bad boy, come on, open up. Open. Oh, shit. All right. So I'm going to stop sharing. I just want to go there and pull that up. We are going to talk about how to read this. What is going to happen? Let me stop sharing. So if you want to, go get that T-score chart and look it up. I will bring it back up here in a minute, but I'm going to stop sharing so you can see me better. Sorry. So. Wow. Oh, cool. All right. So we have this formula here. Let's say that I use that formula and I get like an interval from 15 to 20, right? Let's say I do all the work and I get that interval. And then let's say, all right, and then I go, oh shit, wait a minute. I didn't know that. I only know S. What is S? What is S? What is S? What does that mean in statistics? Can't spell statistics without it. Shut up. Yes, this is sample standard deviation, right? Mu is population mean, X bar is sample mean. Sigma is population standard deviation. S is sample standard deviation. If I took a sample from a population and I calculated S, will that be the same as the population standard deviation? What would you put your money on? Could it be the same? Yes. Will it be the same? I would put all my money on it not being the same, right? If I take a sample and I calculate the sample standard deviation, will that be the same as the population standard deviation? Almost definitely not. Is everybody with me? But I really want this to make sense, obviously. Remember where we started with this? And I replaced this with the next best guess. I replaced the mu with X bar because X bar is our best guess for mu if X bar is all we got. So what I'm saying now is, let's get more realistic here. And in most situations, I don't know shit about some situation. I don't know what the real mean is. I don't know what the real standard deviation is. I'm just generally screwed. So if I don't know what this is, the next best thing I can use is S. Now, everything else is set. Let me make sure I'm missing something right here. I can't change X bar. I'm going to get X bar. I can't change it. It's what it is. I can't change S. I'm going to get that from a sample. And I can't change N. I'm going to have a sample to work with. So it's got a sample size. But tell me this. If I make an interval not using the real standard deviation of the whole population, using an estimate, should I have to make my interval smaller or bigger to cover for me not knowing what the real standard deviation is? What should I do? Should I be rewarded or penalized? If you're trying to catch a certain fish, go back to this analogy. I have no idea. Yes, Ian, trying to catch a certain fish. I love this analogy, even though I hate fish. Trying to catch a certain fish, and the fish, you think it swims like this far away, right? So you think it swims like this to this, and you're not sure though. Maybe it swims this to this. You're gonna have to make your net bigger to cover for not knowing how spread out the fish swims. So if I don't know the real spread, if I've just got an estimate, then I somehow have to make my interval bigger. This, and this are set. I can't change them once I've taken a sample, right? Once I take a sample, I got a sample size, I got a sample mean, I got a sample standard deviation. You ain't gonna change that. So obviously we're gonna change this. And what we call the new thing are t-scores. It looks like a z. So t and z are just one line away from me for being the same thing. It still looks the same. Damn it. So the interesting, real quick little backstory on this. Anybody know a drink called Guinness? I didn't ask if you like it, by the way. I just said you do know about it. A lot of my physics professors drank Guinness. And in grad school, they would invite us out to the pub after class to get some Guinness. I didn't really like Guinness, but I sucked a few of those down. That was a poor phrasing, but I drank some Guinness just to get on their good side. And actually, you know, physics made a little more sense after a few drinks of Guinness. Anyway, so this guy worked at Guinness, the Guinness Brewery, and he did some statistical analysis. He created a new distribution called the T distribution. But he couldn't post this research because Guinness said they owned anything that their employees did. So he submitted this research under a pseudonym. So this is called the student's T distribution. His pseudonym was Student. William Gossett, I couldn't remember his name yesterday. William Gossett was his name. So if you want to Google this guy, you can. He's the one that made this up. So technically, nuts and bolts, when you're doing a confidence interval problem, do you see how the two formulas tell you when to use which sheet? If I know sigma, I can use Z. If I only know S, I have to use T. What also has to be true is you have to have a normal distribution. So first step, do I have a normal distribution? If so, which standard deviation do I know? That is it. How do I tell when to use a Z or T, Jeff? Which standard deviation do you know? That's it. Don't tell me I can use a Z-score because I know the standard deviation. That doesn't make any damn sense. There are two types of standard deviations. Which do you know tells you which one to use. If I only know the sample one, the t-scores will always be bigger than the z-scores, and that's what makes my interval bigger, to cover my ass for not knowing the real standard deviation. It's actually a really beautiful idea. Now, obviously, there's a lot of math that went into creating the specific t-scores. And let me ask you this. If I took a sample of 6 things, how sure am I about the standard deviation I get? Do I feel pretty good about it? Or could it be way off? If I take a sample of 6. Nah, it doesn't. Let me say it like this. A sample of 6 versus a sample of 600. Will my trust in the standard deviation I get change if I go from a sample of 6 to a sample of 600? Hell yes, right? Everybody agree with me? You guys see what I'm saying? So the t-score will get smaller as my sample size gets bigger, because what's the t-score do? It makes the interval bigger to cover my ass for not being sure about the standard deviation. But the bigger my sample, the more sure I am. Hell yes. Thank you, Malachi. So let's take a look at this chart. It's going to say everything. Oh, one last thing before I always forget to do this. All right. Oh, okay. All right. This one's kind of nifty, and I apologize in advance if anybody has any Scottish heritage, because I cannot say this phrase without a little Braveheart sneaking in. There's something called degrees of freedom. You can take away my stats book, but you can't take it. I'm sorry. I'll stop. Lightning comes out of my. Okay, stop. So watch this. This is, now listen. This is a complete side note right now, but it is a big idea and it's on the chart. So I want you to understand it. So this is kind of a side discussion for a second. Degrees of freedom. I can't. If I had 3 numbers and I know that they average to be 10, do you know anything about any of the individual numbers? 3 numbers average to be 10. Do any of the numbers have to be some specific number, or do you know anything about any of the numbers? You don't know shit about any. This one could be 18 billion. As long as this is negative 18 billion, and then this is now here's the point. You do know something about all 3 together. How do you find the average of 3 numbers? You add them up, divide by 3. So what must these 3 numbers add up to be? What divided by 3 is 10? 30. Yes. I don't know shit about the individual numbers, but I do know they have to add the 30. So how much freedom do I have to make shit up before I have to really be careful? So can you give me a number for the first one? Give me a number. 18. And then somebody said 23 is the next thing I see. Now watch, this will still work. Let's see if you guys can think both sides of the number line. If that's 18 and that's 23, and you guys could have typed any damn thing. I just took the first 2 numbers I saw, right? Somebody could have been a real asshole and said square root of 7. Thank you for not doing that. It would still work, but with that. I can't just make up anything for the last number, can I? It has to be what makes this. And right now, I love it. You're right. I've got what so far? I've got 41, right? So what's this got to be to make it become 30? Negative 11. Now, if you don't trust me, add those up, divide by 3. Of course, you're going to get 10. So how much freedom? If I got 3 numbers, how much freedom? How many numbers did I have the freedom to just play with? 2. So degrees of freedom, affectionately known as DF, is always n minus 1. And this is really why. Now, there's more to the math behind this, but this is the fundamental idea behind why the equation for degrees of freedom is what it is. It really is just how much freedom do you got? 1 less than the number of things you got to make work. Okay, I like it. So if my sample size was 18, my degrees of freedom would be 17. Isn't that crazy? Thank you. All right, so I keep forgetting I have an actual eraser. Here we go. Let's try to use this formula. Shut up, Jeff. Use this chart. Oh, I can write on this thing. Awesome. Let me share my screen. Oh, how much time do I got? Not much. Oh, shit. All right. Let me turn on my chat, turn on my people. Okay. And I can write on this. Awesome. So let's say I had a situation. Can I write over here? No, I have to write over here? Yes. All right. Oh, damn it. Let's say let's say number 1. This is going to be exciting. Let's say that I take n of 18, like we just said. Oh, I did forget one more thing. Damn it. Let me see if I can, well, all right. Sorry. If I have a 98% confidence interval, does anyone remember what alpha was? I thought I had everything before I went there, and I'm like, damn it, I forgot one last thing. Anybody remember what alpha was? Not the one in charge of the alpha. No, shut up. Nobody. Alpha was the area in the tails. So what would alpha be here? How much area is in the tails? There we go. 0.02, right? There's 2% in 2 tails. So how much is there in one tail? 1%. I love it. Now watch. Let's go back. Here we go. Sorry if I'm making you sick, buddy. Here we go, guy. Oh shit, we're going back. Bam! All right. Chat. Get over there. People. Okay, I got like dual monitors. Ooh, Jeff, technology. So let's say n is 18. I've got to tell you that it's normal because n isn't big enough. Oh my God. Sorry. All right, that's exciting. It's normal. And let's say I want to make a 98% confidence interval. This is so exciting. Okay. Whew. So what is alpha? How much is in two tails? How much area is in two tails? 2%, like we said, right? Do you guys see right here? It says one tail, two tails. Now in chapter 9, we will have problems where we investigate claims. So if somebody said, I claim the average is more than 80, that would be one tail because I'm only interested in up, above 80. Confidence intervals always make two tails. But either way you look at it, there's 2%. Look right here, 2% in two tails, 1% in one tail. I'm in the same damn column, right? What's the degrees of freedom for this one? Degrees of freedom. 17, yes. So if I find the right column, 2% in two tails, and I go down and I stop at 17, that's the t-score. I would put that into the formula where the z-score normally would go. So the actual work for a confidence interval doesn't change. I just use a different chart to find what to put. Shit, I don't have the formula up there. What to put in place of the z-score. So here, let's try. So that t was, oh, this is exciting. That t was, what was it? 2.567. Holy macarones. Okay, so here, you guys try this one. What if n was 71? Holy shit, and I want a 90% confidence interval. God, I feel like I'm 4 again. Look what I made. So you got to think about how much area is in two tails, so you know which column to look at, and then you got to think about what's the degrees of freedom, so you know where to stop. Degrees of freedom. Yes, Jeff, we know. Did I put that up there? I think so. Degrees of freedom. Oh, Danny boy, the pipes are calling. All right, let's see. King's got a guess. So 90% confidence. Do you guys see how that's 10% right there? 90% confidence has 10%. So when I look at this, I see 99% confidence, 98% confidence, 95% confidence, 90% confidence, 80% confidence. That's what I see because I'm weird. So 90% confidence is this column right here. And I'm going to stop. What's the degrees of freedom? I'm going to stop at, yes, 70. So yes, I agree with you. Right there, 1.667. So the t-score would be 1.667. And you would then throw that number into your confidence interval formula, just like you would with the z-score. So the actual nuts and bolts of the work doesn't change. It's just I have to use a different chart. When do I use this chart to get a t-score? When I only know S. Why on this last problem, by the way? Why was everybody okay with it? I didn't say it was normal. And you're all like, well, yeah, Jeff, we've been talking about this damn thing. Freaking N is bigger than 30, buddy. Yes, that should be like, oh, yeah, we know, Jeff. Shut up. All right, so the first one, of course, I had to say it was normal because it was only 18. Poor little thing. It's not old enough to drink and all that kind of shit. All right. Woo! So I want to show you this. Let me see. Let me see if I can get there. That's not what I want to do. Come on, Jeff. You can do it. You can do it, buddy. You can do this. Did I even put it up here? I haven't put it up here yet, but let me go to another class that I apparently care more about. I'm sorry, everybody. No, this is my this is my class from yesterday. So that's, did I put it up here? Or did I put it in assignments? Isn't this exciting? This is such a brave new world we're in. Here. So I need to put this up in your section. Let's take a look at this weird thing. Open sesame. Oh, brother and a half. Please. Can you guys, yeah, you guys are with me on this, right? T-score practice, you guys see that? So what I'm gonna do is, everybody can see this, right? T-score practice. Is everybody with me? Yes. I want you to try this out, and I will actually create a video and put it up on the YouTubes, on the internets, working this out, this sheet out, because next time I want you guys to work on the other side. So right now, focus on this side if you want. Homework takes priority, but if you do this, it will help you get ready for the homework, is my hope. And then I'll post the solutions up on the YouTubes probably later today, because they need to do it for my other class too. Let me see. And then next time we'll look at the other side. Yeah, all kinds of data. Look at that. All right, sorry. Let me think. What else was there? Oh, very, very important. You ready? Quiz. The quiz. We're going to have a quiz. We're going to have 2 quizzes, dude. One quiz is going to be next Thursday on chapter 8. So quiz on Thursday on chapter 8. And then we'll have a quiz the following Thursday on chapter 9. So those 2 together will be what the next test would have been. What's happening? Oh, I see what you're asking. Let me make sure this next, did I say next Thursday, next Wednesday? I'm pretty sure I did. Dadgummit, Jeff. Do you know what you're talking about? Give me one. Just bear with me. You're like, that's all we ever do, Jeff, is just bear with you as much as we can. Let me double check what my original intent was. The test we were supposed to have on 8, 9, and 10 was the 31st. Yeah. Wait, the 31st. There's no April 31st, Jeff. That's, I love that shit. That's, I personally just love that shit. I think I meant the 30th. So yeah. This is perfect. So the next 2 Thursday, meaning, I'm sorry. So a week from this Thursday. So let me be very, very specific. Can I be specific? Thursday, the 23rd, we'll have a quiz on chapter 8. Yes, Victor. And then Thursday, the 30th, we'll have a quiz on chapter 9 and 10. That should be a remarkable amount of time for you to get the homework done and questions asked and get completely ready for it, I would think. Okay, one reason I'm doing that is because we haven't really finished section 8.2 yet. So we're gonna finish that up on this Thursday. And then I always like to give the quiz a week after I finish lecturing on section. So that's my original thought on that, which I forgot. Okay, so any questions, guys? So I am gonna put this T-score practice sheet up on the canvas, And if you wanna take a look at it, I'm gonna post a solution video to it later today. Oh, Ree, what you got? Let me get this away. Go away. Somebody's got a question about homework. 8197. Let me see. Let me close this up. Do I still have the book open? No. Why would you, Jeff? Why would you? Oh, give me a minute. I got to reopen the book. Dadgummit, GF. Otherwise, if you guys don't want to hang out, you're free to leave. Should say confident. Oh, I'm sorry. Wait. Let me make sure. That was a different question, right? That we originally were talking about. Did they do that twice in a row? Let's see. Come on, internet. Come on, internet. Work for me, baby. Let's see. What was it? 897. Okay. People are leaving like crazy. 97 EFG. No. E, they correctly worded. They want to increase the level of confidence, so they worded that correctly. And they want to keep the error bound the same. So that is pretty much exactly what I was saying earlier about how they could have worded the other one. Yeah. So F is correctly worded. These are correctly worded. The other one, it seems that they worded it so they meant the confidence interval. Is it bigger or smaller? These, EFG on number 97, are correctly worded. So I'll let you know that much at least. And then give them a try. And then you can ask the question if it doesn't make sense still. Okay. Can you go over the T-score chart one more time for how you see the chart for 90? Okay. Where'd you go, T-score chart? T-score chart. I closed it. I am on the ball today. Give me a minute. Sorry, I closed it up. Scheisse. Multiple monitors is useful and confusing. Let me see. Hold on. Where'd you go, T-scores? There they are. I got them. Yay. All right, let me try to share this. You silly share. Catch up. There we go. Here it comes. So I think the question was for the last one we did. So watch this. Let me say this again. I see this as 99% confidence interval right there. Do you guys see that? This one right here, this column is for a 99% confidence interval because a 99% confidence interval would have 1% in two tails. There we go, two tails. This would be 98% confidence because it would have 2% in two tails. This is 95%, this is 90%, and this is 80%. Do not write those on your paper because you're not allowed to have notes on your paper. Does that make sense, Samantha? Yes, okay. So if I ask you to make a 98% confidence interval, you would go to this column because that would be 2% in two tails. One thing I didn't talk about earlier, notice, do you see the numbers at the very bottom? Do they look familiar at all? Any of them? Like this one, and this one, and this one. Those are z-scores, right? So we'll talk more about that next time. So z-scores actually live at the bottom of this chart. What was the other question here? Chapter 8 quiz on the 23rd and chapter 9 and 10 on the 30th. Yes. So you have an amazing amount of time to prepare. What else do we have here? Point 2 is 80%. Yes. Yes, exactly, because it's the area in two tails. So if I want to be 80% confident, I have 20% in two tails. So that last column would be for 80%. But for the 8-1 number 97E, if I want to increase the level of confidence, the z-score changes, right? No. Let me see. Maybe. I can't remember now what that question was. Oh, I closed the book. Jesus. Let me see. Jesus Cristo. Let me see. Where to go? Oh, hold on, Ree. I don't remember what it was. Hold on. Let me see. No, I don't want any of your shit. All right, let me see. Homework. All right, see you, Samantha. 8197. E. if they want to increase their confidence and keep the error bound the same by taking another survey, what change should it make? Yeah, so how can I say this? One way is to change the z-score, but that's going to be a consequence of what they're really going to do. So if you want to keep your net as big as it is, you don't want to change the size of the net. That's what they're asking you. So they're actually saying keep the z-score the same, to be honest. But they want to increase how confident they are. This is kind of a weird question, but what do you always do to increase how confident you are? Always. How can you increase how confident you are in statistics? You take a nap. No, you take a bigger sample. Yep, take a bigger sample. So, you're right. The consequence of that is the z-score would have to get bigger, but that is achieving their increasing the confidence level. You don't just increase the z-score, you increase your sample size. Yeah, okay. I basically gave that one away. All right, anything else? Did I miss anything? No. All right. Who's still here? A lot of people. Maybe some of these people were never really here. I'm curious. Anybody else who's here, you got a question? You got to remember, we're supposed to end at 10. So if you log in and then go back to sleep, you want to set your alarm for 10 so you can log back out. So it makes me think you were really here. If you're all really here, I apologize. I'm sorry, but I'm still here. Who will be the last to leave? If nobody asks me a question in the next 3 seconds, we're all going to leave at the same time. 1, 2, 3. Bye, everybody.